What's up, music nerds? I'm reading Hermann Helmholtz On the Sensations of Tone, and today is a very exciting day because we've made it to part 2 on the interruptions of harmony. The link to the webbook that I'm reading from is in the description below. You can find the entire text of the book there, as well as all the apps that I'm going to show you in this video. So let's get to it. Chapter 7, Combinational Tones. Combinational tones, which were first discovered in 1745 by Sorge, or Sorg, a German organist, and were afterwards generally known through the Italian violinist Tartini, from whom they were often called Tartini's tones. These tones are heard whenever two musical tones of different pitches are sounded together loudly and continuously. The pitch of a combinational tone is generally different from that of either of the generating tones or of their upper harmonic partials. We know this from experiment. Unlike upper partials, the combinational tones are not heard when each of the generating tones is played individually. They only sound when both generating tones are played together. So what Sorge and Tartini observed are what Helmholtz is calling differential tones. Their pitch number is the difference between the pitch numbers of the generating tones. And Helmholtz has also discovered summational tones, in which the pitch number is the sum of the pitch numbers of the two generating tones. In general, the differential tones are stronger than the summational ones, and the stronger the generating tone, the stronger the combinational tone. And if they are strong enough, the upper partials can also produce their own combinational tones. Let's try and hear some combinational tones here. So this note with the hash mark above it is our differential tone. If we play a note a half step up, we should hear some beating from it. And Helmholtz has calculated the combinational tones of some standard harmonic intervals. Let's go back up to our app here. When I play the combinational tone, I get more combinational tones. He's called these the combinational tones of the second order. Here we have the differential tones of different orders for different intervals. The generators are minimums. Combinational tones of the first order, crotchets. Huh. Okay, so I guess half notes are minimums, quarter notes are crotchets, and eighth notes are quavers? I've never heard that before. But the octave is in unison, the fifth. Now moving on to summational tones. These are weaker, and really only the first order can be heard. And you can hear some of those summational tones are not as harmonic as the differential ones were. So where are these combinational tones coming from? Well, one clue is that they're very powerful in the polyphonic siren. you can go back and watch my video on chapter 1 to get a refresher on the polyphonic siren. So because the air is being set into vibration by two different rows of holes simultaneously, the combinational tone exists in the air itself. And we can use resonators to hear it more clearly. However, these combinational tones also must be generated in the ear, because in the case of two separate tones coming from two separate singers, for instance, the combinational tones are not reinforced with a resonator, but they can still be heard quite powerfully in some cases, so we must assume that these tones are being produced within the ear. Now, it so happens that in the construction of the external parts of the ear for conducting sound, there are certain conditions which are peculiarly favorable for generation of combinational tones. First, we have the unsymmetrical form of the drum skin itself, its radial fibers, which are externally convex, and the loose formation of the joint between the hammer and the anvil. The importance of combinational tones in the construction of chords will appear hereafter. We have, however, first to investigate a second phenomenon of the simultaneous sounding of two tones, the so-called beats, which we will get to in the next chapter. If there was anything in this chapter that you want to read in more detail, or if you want to go listen for some more combinational tones with that app, go to sensationsoftone.com, and I'll see you back here next week for chapter 8. Bye!